Hi everyone, it's Coach Fred here, and today I'm doing my daily SAT ACT strategy concept video. So today I'm going to talk about absolute value equations and inequalities and their special rules. So to do that, I think on the ACT especially, they're really wanting to test your understanding of definitions, theorems, and properties of algebra. So let's talk about the definition of absolute value. Absolute value is the distance that a number is from 0 on a number line. So, for example, the absolute value of -2 is 2 away from 0. If I said to you the absolute value of x minus 2 is 5, that is saying from the point 2, I have two x's, some x and some x, that are 5 away from that number. So I could go 5 in this direction, and I would be at 7, and I could go 5 in this direction, and I would be at -3. Both of those numbers, -3 and 7, satisfy this equation. But let me think then, if distance is always positive, could this ever be true? Is there any number that x could be that when you take its absolute value will equal a -2? And remember, equals means is the same as. So this special idea is really just to identify the definition or think of the definition of absolute value. There is no number that we could plug in here for x that would give me an output or an equals -2. So no solution. There's no such x. All right, but now let's throw in inequalities. And let's think about what it actually means. Now remember, if I give you the absolute value of x plus 1 equals 2, what that means is the distance from -1 to x is 2 units. So when you learned about absolute value equations, I'm hoping that you learned how to turn this equation into a verbal model, okay? The distance from -1 to x is 2 units. All right, now let's throw in, let's make that an inequality. All right, so let me get rid of this. Now what if I said to you the absolute value of x plus 1 is less than -1? Well, that means then what you're saying, if this is a true statement, is the distance from -1 to x is less than -1 units. Well, you can't have a distance that's -1 units, so this is an inequality, a less than inequality, which is impossible. It has no solution, okay? I guess the big question now would be, what if it was a greater than equality? Okay, so let's consider greater than. What if I said to you the absolute value of x plus 2 is greater than -1? Well, if you think about this, no matter what number I plug in for x here, no matter what, I'm going to take its absolute value. So it will always be greater than -1. And so therefore, if this is an absolute value inequality and it's greater than -1, then the answer would have to be all real numbers. Okay, guys, these are the 3 special cases for absolute value that I see come up on the ACT and the SAT all the time, if they do include an absolute value in equation or inequality. All right, so let's look at an example of an ACT problem where this might come up. Okay, so here we're looking at number 57, which says, which of the following number line graphs shows the solution set to the inequality? So first, I identify that it is an absolute value inequality. So the absolute value of x minus 5 is less than -1. So I want to think about the definition of absolute value being distance on a number line. So no matter what, every value that I put in here, once I take its absolute value, is going to give me a positive number. So it could never be less than a negative number. So the answer would be no solution, so empty set. Now, it's very tricky because, a lot of kids are going to use the process of solving an absolute value inequality and not really consider that negative value. It's question number 57. We're almost at number 60, so we're in the more difficult questions. So you really have to consider the concept and the definition of absolute value. Hopefully that was helpful. Have a great day.